right? So dn by 2 and dn by 2. Now, we have, again, we separate it down, down and down until we get a single element, right? And then essentially, once we have single elements, we just need to merge them back up together, which requires d of that number of elements to combine them. Now, if we have this particular tree, can someone tell me that if the number of elements of my array is n, what is the height of my tree? If the number of elements of my array is n, and I'm always dividing my array into 2 halves, what is the height of my tree? Log n. Perfect. And then we have, for every point or every level of my tree, I need to combine those arrays together. So for the final level, I have a time complexity of dn, but for the second level, I have 2 time complexities of dn by 2 and dn by 2. So if I combine and sum up all of them together, I again have a time complexity of dn, right? And for 4 quarters of dn by 4, I again have a time complexity of dn, and so on, until I reach all the levels of my, all the leaves of my tree, and I combine all of them together as well. So for each level of my tree, I have a time complexity of dn. And I know that there are log n levels of my tree because I have a height of log n. So what would be the time complexity of this particular recursion tree? Where for each level I have d of n, d times n, and I have log n levels. Exactly, right? So I have log n levels, and for each level I have a time complexity of d times n. So I have an entire time complexity of n log n, right? Perfect. So now let's look at this particular equation here. We have Tn equals to Tn by 2 plus theta 1. Now this we will try to solve using the iteration method. That is similar to recursion tree, but essentially we are going to evolve our equation and recursively find out what's going on. So we have Tn equals to Tn by 2 plus 1. Then essentially we can say that that equals to Tn by 4 plus 1 plus 1. Right, because essentially Tn by 2 is essentially Tn by 4 plus 1, and Tn by 4 plus 1 plus the entire of T of n becomes Tn by 2 plus 1. So essentially Tn by 4 plus 1 plus 1, and that is Tn by 8, 1 plus 1 plus 1, and all the way up to T of 1, 1 plus 1 plus 1 plus 1, blah, blah, blah. So we see here that every time we recursively call our function, and we can look at this particular thing in more detail here. So let's say that we have T of n equals to T of n by 2 plus 1. Now, what is Tn by 2? So Tn by 2 is going to be the same according to the same function above, T of n by 4 plus 1, right? So if we substitute that with the previous equation here, we get T of n equals to T of n by 4 plus 1. So that is Tn by 2 plus of 1, that is from the previous equation there, right? So we have T of n by 4 plus 1 plus 1. Similarly, we can also go much deeper. We have T of n equals to T of n by 8 plus 1 plus 1 plus 1, right? So we do see some pattern here. So can someone tell me what would be T of n if we are trying to do T of n by 16? How many ones would I need? 4. And how did we get to that particular value of 4? Because every time we are halving the number of n's and we are adding 1. So essentially that becomes log of n times of that particular number. So if we iterate down all the way to a t of 1, exactly log of 16, right? So if all the way down to t of 1, we have log n number of ones, because for every time we are having the number of n, we are adding 1. So we have log n of numbers. So we can say, using the iteration method, that t of n equals to t of n by 2 plus 1 results in log of n complexity. Okay. Now we have, let's look at another time complexity algorithm, that is t of n equals to 2 times t of n by 2 plus of 1. Initially we looked at d of n, d times n, but now every time we are merging it, we have a time complexity of 1. Right, so we divide it into 2 halves, 4 halves, 4 quarters, and all the way up to theta of 1. So we have again a height of log n as we had earlier. Prajakta, what do you mean by 0? So for each level now, we have, and Prajakta, do answer you this question and I'll come back. So for each level, we have, so for each level, for the first level, we have a complexity of 1. For the second level, we have a time complexity of 2. For the third level, we have a time complexity of 4. All the way to the number of leaves, we have theta of n. Now, how do we compute the time complexity of this particular thing? For this, before I explain this, I want you guys to give me an estimate of what is the time complexity of this particular thing. What is the time complexity of this recursion tree? N log n squared, n factorial. I see log n, I see 2 n log n's. Cool, you're all wrong. Okay, so do one thing. In order to compute the time complexity of this tree, we need to count the number of nodes there are in this tree. Initially, we had a summation of dn all that way for each level, but now we don't have a same summation every level. So all we need to do is compute the number of nodes in a tree. So can someone tell me that formula for the number of nodes in a full binary tree? Given height h, in terms of h, tell me the number of nodes in a tree. Because that is what we need to do, right? We need to compute for every node here, we need to add 1 to it. So essentially, we need to find out the number of nodes in my tree, and then that would be the time complexity of my algorithm. Does everyone agree with that? That if I count the number of nodes in my tree, that is the time complexity, right? So we have h to the power of 2. Parvez, I think you are in the right area, but not the right answer. We have 1, 2 to the power of h from Yaswanti. Anybody else? What is the number of nodes of a full binary search tree? So we have a few 2 to the power of h. So let's go with height equals to 2. So if we have height equals to 2, we have 1 here and the second level here. So in that case, I have height equals 2. So 2 to the power of 2, that gives me 4. We know that there are 3 nodes. That essentially means it can sort of be 2 to the power of h minus 1, right? Right, that looks like it. So let's go with height 3. So for height number 3, we have 1, 2, 3, 4, 5, 6, 7, I guess, yes. So height 3, 2 to the power of 3, that gives me 8, minus 1, that gives me 7. So does everyone agree that 2 to the power of h minus 1 sort of gives me the number of nodes in my tree? Cool. So now tell me the number of nodes in this tree. where height is h or log n. I need some more answers, but yes, you guys are correct. But does everyone agree that they are correct? Interesting answer, Pervez. I will come to your answer in a second before I see other answers. Any other answers? Anybody else paying attention to this particular thing that's going on? Oh, you guys will suffer in the exam. Okay, cool. So, your brain is still in progress. So essentially what I said is essentially the number of nodes in my tree is going to be 2 times h, that is the height of my tree, minus of 1. So in this case, since the number of the height of my tree is log n, we can say it is going to be 2 to the power of log n minus of 1. So that is what people are saying. Pervez, can you tell me why you typed in n minus 1?
I was probably mistakenly assuming that 2 to the power log of n boils down to n. So that
Why
might be
does
a
2 to the power of
miscalculation.
why did you think that 2 to the power of log of n boils down to n? Again, don't be shy, you are right.
Because I mean, what would be log of n? Log of n is like what is how many power of what's the power of 2n can be expressed in.
Exactly.
So
exactly, you are correct. Okay, so let me explain what Pervez is saying again. So we have 2 to the power of log of n. And before I try to explain this thing, what is the base of this log? What is b? Can someone tell me? 2, 4, 8, 24, whatever. 2, everyone agrees? 2. So base of this thing is 2. So what is log? So what is log base 2 of n mean? So it essentially means that if it equals to some value, let's call that value x, right? So it means that 2 to the power of x equals n. That is the property of log, right? So base of something raised to the power of the answer should equal to n. That is the meaning of log, right? We discussed about this earlier. So if log base 2n equals to some value x, then when we say log 2 to the power of log base 2 of n, we can say that it is 2 to the power of x, right? Because log base 2n is going to be, we consider this value to be x. But we also said that 2 to the power of x, based on the properties of log, 2 to the power of x is going to be n, right? So we can then say the complexity is n minus 1. Does everyone understand this? How the time complexity of this is n? So the number of nodes in this particular array is going to be n, right? Exactly. So the time complexity of this particular problem is theta of n. Similarly, we also have Tn equals to Tn minus 1 plus 1. We can again iterate through this particular thing, Tn minus 1, Tn minus 2, and so on, each time adding a 1 to it. And that essentially means that